Hello everyone, this is Himabindu from the Department of CSIT. Today in this video, I would like to explain about the conversion of regular expressions to finite automata. So in previous videos, we have discussed about the regular expression, how we have designed from the finite automata. And here in this video, we will discuss about the conversion of regular expressions to finite automata. So here are the finite automata examples. What we have to the regular expressions contains these symbols. How we have to form that into a finite automata. So here it is a case one. So if it is the regular expression having a plus b, how we have to write this a plus b in the finite automata, in the sense the regular language here it is having either it is starting with either b or a b, and so there is epsilon also included. So here and so on. So this is the language. For this kind of languages, we will write this. So a plus b whole a plus b. So the string is going to be starts with this q naught, and so either it is going to be starts with. So we already discussed final states and initial states in the first videos. So here the string or this regular expression starting with either a or b. So that is denoted by this one, like this. A, either it is starting with a or b. It is reaching the final state. So this is how we have constructed given regular expressions to a finite automata when we saw this kind of expression in the regular expression. And here how to denote concatenation. So concatenation, first initial state q naught, and we will take q1 and qf. Qf is the final state. So how to define this AB concatenation in the finite automata A, B. So it is reaching the final state. When we saw this AB in the any transition regular expression, it is formed like finite automata like this. And when we saw the A star, so A star here only A star is there. So here I am starting with the equation initial state with the q naught, and only one symbol is there, so I am taking it as a final state also and giving the input as a and with the multiple times. So here it is the a star is denoted, and we also write a plus b whole star also. How we have to write this a plus b whole star in the sense same thing. So when we are taking as an initial state and final state as the same thing, and we have to give the two inputs symbols at a time. So a plus b, I am returning it as a comma b. So this is how we have to solve the regular expressions to a finite automata. So we in the every regular expression, if you saw this kind of regular expression, we have to write this finite automata. And next, convert the regular expressions to their equivalent finite automata. So here are some examples of that. Let's solve this equation. So first, when we saw the regular expression, try to find the languages for that one. So what are the languages of the regular expression in the sense? So it is starting with B and having the a star in middle. So in between A and B, so B is starting and ending is B, and in between A star is there. So A star, we already know that A star representation, it contains epsilon comma multiple A times and so on. So here epsilon also. So minimum length, how to form that minimum length here in the sense we are including the epsilon, that is nothing but BB. So we can say that it is a BB, comma BA, B and B multiple times BAA, B and BAA, B. So this is how we have to form that language. For this kind of language, how we will write this regular expression into a finite automata. So the final starting state is a Q naught I am taking, and it is starting with the B, and it is having ending also with B. So it must end with B. So it is reaching the final state. So here reaching the final state. So in between B, B, we have A multiple times. How I have to return this one in the sense A. So by in middle of this starting and final states, we will give this A star. So how to represent this A star? In the previous slide we discussed. So this is a representation. So here that's why we have written like this. So what is the finite automata for this kind of regular expression? And next we will move to the second one. L is equal to, so this is the A and A or B. So A or B, in the sense the string is going to be start with either A or B. So let's form the equation language. So I am starting with A, and the C is must and should here, comma, and I am starting with B and C, and here only these are the two things. So here how to form this regular expression? We have to start with the equation Q naught, and it is the initial state, and if it is having the state, so here it is forming with the multiple state, so two inputs. So how to represent the two inputs? In the sense we have to take one more B as a state. We have to take these two inputs and reaching the final state with the input symbol C. So this is the final state. So this is a mediation state. So here we will take these two input symbols, either it is starting with either A or B. So this is how we denoted this regular expressions to a finite automata. And next take this A, B, BC whole star. So L is equal to, so it is the starting is must and should A and B. So here we will say that BC whole star contains epsilon plus epsilon, epsilon comma BC, 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 comma BC, BC 3 times. So this is how B star represent. So epsilon is included in the BC star. So I am writing this epsilon, that is nothing but A, comma A, BC, one time BC, and A, BC, BC, and 2 times A, BC, 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 and so on. So this is the language. For this kind of language, how we will construct a DF, how we will construct a finite automata in the sense. So we have to start with the equation Q naught starting state, and for this we have A as a final state, A as a state input symbol, and it is reaching the final state. So this minimum length is satisfied with this equation. After this we have to take this equation, take this string, and let's draw this. So QF we will take it as, and if it is having the input symbol BC, so we have to take one more state, and we will name it as a Q1, and here B I am taking the input symbol, and C. So this is, there is a repetition of loop whenever after seeing the input symbol of A, how many times BC is there in the input string, it is reaching the final state. So this is how we have to form the regular expression. We have to form the finite automata from the given regular expression. And here we will convert the regular expressions to a finite automata with the regular expression what we have taken as an example. So let's take this example, and we will in steps. Step 1, what we have to do, so there is a plus symbol in between the two things. We will separate these two. So step 1, what we have to do, just to draw the step 1. So we have Q naught as an initial state, and QF will take the final states. It is representing like this, and in between we have to write the regular expression. So how to form this one? So step 2, Q naught I am taking. So Q naught. So we have taken this. So whenever if you assume like A and B, how to represent A plus B? So we have taken the final state F. So if it is A and B, so A and B, so that is represented as Q naught. So A is equal to 1 0, and it is reaching the final state, and B is equal to, or all we have to write is 0 plus 1 1, 0 star 1. So let's solve this one. So step 3, so 3 contains, so initial state Q naught, and we have to solve this 1 0 and QF. So after this one, there is a concatenation among these three. So A, B, C concatenation. So let's find this A, B, C concatenation. So I am taking this on one more state Q1, and for this one 0 plus 1 1, and for the 0 1 we are taking 0 star 1. So and after this one we will write in step 4, we will write this equation Q naught as an initial state, and we also write in 1 0 QF final state, and for this one I am writing a Q1, and let's solve this 0 star. So 0 star we will give this like this 0 star, and we will take it as a 1, and here 0 plus 1 1, and here after this one, so 5 equation number 5 step. So in the fifth step, Q naught as an initial state, and we'll give one more state in between Q2, and here I am dividing A dot B. So AB. So 1 and 0, and final state is a QF, and here in between we have taken, here also plus symbol is there, we are dividing this one. Both are given to the same state Q1, and the self loop zeros, and it is divided 1. And after solving this fifth equation, we will fifth diagram, finally what, how we have to solve this one more 1 1 is there. So one more state we have to add in between this. So finally the Q naught, so it is having the Q2 as state with the 1 input and 0 input. It is reaching the final state, and here 1 1 is there, so one more state we are adding Q3, and here Q0 Q1 we are taking this 1 1 representation, it is reaching, and 0 with the self loop 0, and it is reaching the Q1 with the input symbol. So this is the final finite automata for the given regular expression. So this is how we have to solve the step by step these regular expressions into a finite automata. And next take one more example. And here in previous example we have taken 0 1 binary numbers, and now in this one I will take A comma B as a input symbols for the regular expression. And how first step what we have to do, so Q naught we have to start with the Q naught, and this is the initial state, and here we have to write the regular expression, and here it is a plus symbol is there, so B A B star A, and it is reaching the final state QF. So we have to divide this like A comma B. So A plus B, how to define that A plus B? This is the first one, and second one, so we have to start with the Q naught as an initial state, and we have to take the final state, and here A is represented as AB, and here one more B plus A, B star A. In the third step, we have to divide this concatenation and we have to add states to this concatenation. And how to add this states? Q naught, and we have to form A, B, and here also we will add one more state to this one. So for the representation of concatenation, we will add one more state in between this Q1, and we will name it as a Q1, and we will give the input symbol B, and it is reaching the final state QF. And after solving the AB concatenation, we have to solve this 3 concatenations. So here we are taking the Q2 as one more state, and here for the Q2, the input symbol is B plus A, and it is reaching the Q2. And if you give the B star A as an input, it is reaching the final state. And here we have to solve this equation. So solve this B plus A, and here we have to initiate with the Q naught, and it is having the A as an input symbol, and it is reaching the Q1 state, and it is reaching the final state with the B input symbol. And here we are taking one more state Q2, and with this A plus B, how we have to do this? So A plus B from the starting state to Q naught 2. So it is reaching the final state with the, so like this we have to write this 2 B A A. And here after this one, so B star is represented the self loop B, and we have to give the A as an input symbol. So after solving the A, we have to add one more state to this one, and the fifth step Q naught, and here A, Q1, and QF, B as an input, and it is reaching A. One more state is added here, Q3, name it as a Q3, and A, it is reaching the final Q2 state with the B, and here I am meeting A as an input, and here only 1. So after solving this one, this is the final state, final representation of the finite automata for the given regular expression. And next example. So here we have taken the example A star B star. So here for how to solve this one, in the sense we have to solve this equation with the first step. What we have to do, Q naught we have to initiate. So Q naught initiation. So there is a concatenation A, this is A, B. So how to solve this one, A, B. So concatenation, so in between one state is there, Q1, and reaching the final state, QF. So if it is A as an input, and this one A star, B, A star, B, A star, whole star. So for this one, what we have to do, first A star we have to identify. So Q naught, the Q1, with the A input symbol, and after this one, we have to find the states for this one. So this is all the self loop. So we have to find this. So first solve this equation. So A holds A remaining B star. So B star, so let's form first equation. So A must be there, and here this entire B star representation also include the epsilon symbol. So epsilon, comma B, and A star, B, A star, B, A star, and so on. And so on. So for this first attempt, A comma, all this will be happened. So A into epsilon. So after giving the input symbol A, it is reaching the final state. So we will take only final state 1. For this one, first we have to do the concatenation of all these things. So concatenation, first step A star we will do, as a self loop, and after that if you give B as an input symbol and it is reaching the one more state, Q1, it is naming as a Q1, and after this we will name it as a, we will take BAB, and next and B. So A star will be like this. So after converting all the equations, we will represent this equation in the form of Q naught. So and A as an input, and it is reaching the final state. So with the self loop A star, and one more state is there. So what is that? Q1 is the state. So after giving the B as an input symbol, and if after solving the A star, we will get. So this is how we represented the regular expression from the regular expression to a finite automata. So the finite automata which is having the input symbols A comma B. So and these are the references, these are the examples where we have taken, and that's all about the construction of regular expressions to the finite automata. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.